Hi, hi friends. Yeah, first I want to thank you, everyone that has organized Spaghetti 8th. It's like an amazing event. I think it's the one I've been that kind of has kind of involved the local community more, and I think it's awesome. Um, the presentation is not very long, so perhaps we have like some time after for question debate, or perhaps I can show you now that I'm in Italy, show you Fibonacci writing in Chiquito. And yeah, so that's like I'm Leo Lara. I've been doing software engineering all my life, and yeah, I've worked in distributed software, server software, and recently kind of I did the jump to blockchain, and now working on the CKVM in the PSC in EF. No, so that's kind of my introduction. No, when I got to this field as a software engineer, I saw like there is kind of like the dynamics. There is a lot of academic research being done every day because it's a very new field. Then there is some kind of genius programmer that is from this academic research is able to code like a proof system, and some even more genius person is kind of like being able to write circuits on this, especially for more bleeding edge CK proofs, no, to build like a CK circuit. And it's kind of very, very difficult for the average programmer to kind of get involved. And that's kind of what we need if we want to get to the infinite garden of CKP, you know, like building like be like for idiots like me, no, in my team, everyone is super smart and not a lot of math, but we need to make it accessible to the average developer like me, to be able to kind of build an infinite garden that have all these possibilities that the previous presentation was talking about, and kind of really get to to the the extension of these to all the fields. No? Because as they were saying, like this is beyond the blockchain. And there are kind of two solutions that are being developed for this problem. The one is the CKVM for general purpose of, I think the most famous system for this is called Risk Zero, probably. So you kind of, they have a proving system that is kind of runs any risk v risk 5 software and kind of generate proof from any risk 5 software that has been executed. And that's one approach to kind of make it like easy for every developer to work. And then there is the approach of trying to start developing higher and higher level of like higher level tools and languages for CKP. And I'm going to talk about the second approach, and I think both has to coexist, because even to build the first one, you need the kind of to write the CKV circuits, the CKP circuits directly. So both are going to coexist in different terms in the future. I don't know the proportion in the future, but both are going to exist. So what we want? We want kind of like a toolchain. We want the typical toolchain we have in software engineering for CKP, and this doesn't exist yet. From the working on the CKVM, no, this is such a complex. It's probably the biggest currently CKP project, no, and the biggest CKP circuit that exists. No, we are trying to validate the Ethereum level 1 blocks, and just on top of the proving system that we use, that is called Halo 2. It's impossible to build such a complex software. So kind of ad hoc as the project has been kind of running, we have been building all these tools, libraries, and abstractions on top of it. It's impossible to build it without creating more abstractions on top of the proving system. And basically, from that kind of came the idea of Chiquito Pecador Plonkish. So this is a high-level abstraction that is using kind of putting in a language all this abstraction we have built for the CKVM. No, it's currently we started working on it. I mean, I started with some people I started myself in March, no, and now there are more people contributing. yeah, we have a working prototype. Like there are one part of the CKVM that has been ported to Chiquito. This has like a front end in a Rust DSL and a backend for Halo 2. And it can also connect with other circuits in Halo 2. So you kind of integrate it in a bigger Halo 2 circuits like the CKVM. I think I want to show this like example of code. So this is one of the constraints that make the CKVM that is, yeah, perhaps not, I see the camera working, perhaps not very readable. I'm sorry. And so this is one of the rules. There are more like 6,000 of rules like this, of constraints like this in the CKVM. So this is with all the abstractions that we have built already into the CKVM software. This is how it looks like. It's kind of more readable. That if we like, that's kind of like back converted to pure Halo 2. If we had tried just to write it in the pure Halo 2, that's how it have looked there in there. And there are like more than 6,000 of these. So it's kind of like becomes kind of unmanageable to kind of write code on top of a proving system directly. We need like higher and higher programming languages and higher abstractions that just signals and constraints. And this is how it looks now in Chiquito, no? So this is how it's in the CKVM, and this is how we kind of like you can start understanding and reading what it means and what it does, no? Like, and that's kind of what we are achieving, and I think we can, this can enable like more and more and bigger projects in the CKP space. The architecture, so this has been built like a normal compiler. So there is like not a parser and a lexer. There is a DSL in the front, but this builds like an abstract syntax tree. And from that gets compiled to an intermediate representation that is Plonkish and is compatible with other Plonkish proving systems. So in the future, we are going to have like, there are already people working on a Python frontend. So you will be able to write Chiquito circuits in Python directly. And you will also, like in this example, Sangria, but it seems like Hypernova would also work. So we will be able to compile to different proof systems. So this kind of like is part of make it part of a bigger tool chain that will enable developers really to do amazing things that they are not possible now, or at least they are super difficult. No, so this kind of improves the readability, the learnability, and the teachability. Like teachability, if that's a word. Like I've been in a hacker house recently, and we had developers that just started in CKP, and they were writing complex circuits in Chiquito in 1 week, like the MIMC hash or the Poseidon hash and such. No, and kind of like abstract complexities. We cannot build this infinite garden of CK. So this is comparing with other kind of languages. So we feel we have been researching the other languages that exist, and we feel pretty confident that is the highest level programming languages for CKP that currently exist. So most of the programming languages kind of stay at the level of signals and constraints, and kind of we go much further with kind of higher and higher abstraction. This is a bit like these languages kind of are based in Go2, and we are kind of in structure loops and that kind of thing, if you kind of compare it with the history of programming languages. So the vision is kind of to be like AI has so much explosion, and one of the reasons is like they have been developing more and easier and more abstracted to like for example PyTorch. So I had some colleagues that told me this is like what you're trying to do is kind of like what they were doing with PyTorch in the artificial intelligence space. If you want to know more and receive more information, join this Telegram group or in Discord in PSC. There is a Chiquito channel also. Thank you very much, and please throw away any questions or anything that we can want to debate, or yeah, perhaps I can show the Fibonacci if you're interested. That's it.